Hello everyone. Today I want to summarize our new article, How a Machine Can Understand the Command Intent. My goal is to give you a brief summary of our work so that you can decide whether or not you want to read the entire article. So let's dig in. A commander has an intent. The intent is not for you as a soldier to stand next to a certain tree, but the intent is to achieve a desired outcome, for example, prohibiting the enemy of approaching or destroying the enemy. By stating the intent rather than a task, the commander is enabling the soldier or the subordinates to create initiative, to display behavior that is in line with the intent but can react to unforeseen circumstances. This is also why a commander then briefs their subordinates using their intent. We are very interested in creating decision support systems that help military commanders during the executions of their missions. During such an execution, a commander does not have time to interact with such a system very longly, to configure it, maybe even to write computer code. So how can we make sure that the commander is able to effectively communicate with such a system? In this work, we have taken the approach of understanding the natural language of the commander as a way of interfacing with the commander. This means that the commander should be able to just state in his own language what his intent is, what he wants to achieve, and the system should be able to understand it and react it and provide decision support. This article therefore has three objectives. First, we need to be able to understand what the commander is saying in natural language. Second, we want to brief back to the commander and really indicate that we understood the intent correctly, or let the commander make adjustments. And thirdly, we want to use this commander's intent as an executable evaluation function so that a reinforcement learning agent can use it in learning good behavior. So for the first goal, we have defined a grammar that can analyze the commander's intent. On the top left, you see here a commander's intent, which is just an example. Real intents are much longer and much more detailed. But here you can see that the blue commander's intent is to secure the area south of Bridge Alpha. And in the event of incursion of enemy forces, we will counterattack. Blue Squadron 1 and 2 will not allow the progress into south of Bridge Alpha. And the end state is achieved when there are no more enemies inside south of Bridge Alpha. On the right side, in table 3, you see a verb frame, which is part of our grammar. So when the commander is talking about securing something, we know that there will be a tasker and a taskee involved, possibly a facility or feature, a certain location, a start time, possibly an end time, and a reason why we want to do this. We are using Spacy to analyze the natural language of the commander and to understand the sentence structure to get elements out of a written sentence and place it into the verb frames. The result looks somewhat like this. So on the left, you see here the same intent, but now certain information is being split up into smaller tokens. So for example, the first key task is that we want to perform the action, which is the counterattack, and the affected is the enemy forces. It's not parsed perfectly yet, as you can see, but the most important information is correctly placed into the different categories. On the right side, you again see table 1, which is the reference intent used for this example. In our work, we also created some measures that are similar to the precision and the recall that you already know, that are able to detect how well our method currently works. The results are still preliminary, as we did not have many intents to be able to test this. So the second step is backbriefing the intent to the commander. Here you see on the left a first way of doing that, which is highlighting words that we already know. This system will have a connection with a command and control system, a C2 system, and any information that has been recognized and is already stored in the C2 system can be highlighted. Also, verbs that are very important here, such as secure or counterattack, are being highlighted to indicate that we understood this verb correctly. In the middle, you see again the parsing into the formalized intent, just as before, but now in the highlighting towards the interface of towards the commander. A second way of backbriefing that we understood the command intent correctly, you see on the right side a visual representation of a map overlay, so to say. Here you can see that we draw the tactical arrow of a counterattack of the troops performing the counterattack towards the area that we have detected. A map is a very natural way of interfacing with military personnel, as that is what they already do during their regular work. In the third part of our article, we are using the command intent as an evaluation function for a reinforcement learning algorithm. On the left side, you see a JSON format of this evaluation function. We choose to make this as a simulator agnostic format so that any kind of simulation could be able to evaluate such a command intent. In the middle, you see one important feature for the user interface towards the commander. All elements of the command intent currently still have the same weight. They are equally important. However, the commander finds certain aspects more important than others. It's very unlikely that they're all equally important. So we are asking the commander here what elements are more important than others and what are their specific weights. This forces the commander to make important decisions. Is it more important to keep your troops alive, or is it more important to gain territory or to defend a certain territory? This has much effect on the desired outcome of the mission. On the right side, you're seeing 4 heat maps. A reinforcement learning agent has used the commander's intent to learn behavior and to place troops on certain locations. So on the top left, the commander's intent was mainly to survive, to keep your forces alive. In that event, the reinforcement learning agent learned to stay on the south side of a river. The enemy is approaching from the north, by the way. On the top right, you're seeing an intent where the commander said that the most important aspect is to eliminate enemy troops. In this case, the reinforcement learning agent learned that you have to move your troops to the north side of the river because then you are more likely to engage the enemy. So this includes my brief overview of this article, how a machine can understand the command intent. I hope you enjoyed it and it helped you in deciding whether or not you want to read the entire article. You can find the link to download the article below in the comments and also how to reference this article in case you want to. Bye bye.